In physics, a string is a physical object that appears in string theory and related subjects. Unlike elementary particles, which are zero-dimensional or point-like by definition, strings are one-dimensional extended objects. Theories in which the fundamental objects are strings rather than point particles automatically have many properties that some physicists expect to hold in a fundamental theory of physics. Most notably, a theory of strings that evolve and interact according to the rules of quantum mechanics will automatically describe quantum gravity. In string theory, the strings may be open or closed and may have other special properties. Prior to 1995, there were 5 known versions of string theory incorporating the idea of supersymmetry, which differed in the type of strings and in other aspects. Today these different string theories are thought to arise as different limiting cases of a single theory called M-theory. In theories of particle physics based on string theory, the characteristic length scale of strings is typically on the order of the Planck length, the scale at which the effects of quantum gravity are believed to become significant. On much larger length scales, such as the scales visible in physics laboratories, such objects would be indistinguishable from zero-dimensional point particles, and the vibrational state of the string would determine the type of particle. Strings are also sometimes studied in nuclear physics where they are used to model flux tubes. As it propagates through space-time, a string sweeps out a two-dimensional surface called its world sheet. This is analogous to the one-dimensional world linear traced out by a point particle. The physics of a string is described by means of a two-dimensional conformal field theory associated with the world sheet. The formalism of two-dimensional conformal field theory also has many applications outside of string theory. For example, in condensed matter physics and parts of pure mathematics. Types of strings: closed and open strings. Strings can be either open or closed. A closed string is a string that has no endpoints, and therefore is topologically equivalent to a circle. An open string, on the other hand, has 2 endpoints and is topologically equivalent to a line interval. Not all string theories contain open strings, but every theory must contain closed strings, as interactions between open strings can always result in closed strings. The oldest superstring theory containing open strings was type 1 string theory. However, the developments in string theory in the 1990s have shown that the open strings should always be thought of as ending on a new type of objects called Jbourjai, and the spectrum of possibilities for open strings has increased greatly. Open and closed strings are generally associated with characteristic vibrational modes. One of the vibration modes of a closed string can be identified as the graviton. In certain string theories, the lowest energy vibration of an open string is a tachyon and can undergo tachyon condensation. Other vibrational modes of open strings exhibit the properties of photons and gluons. Orientation strings can also possess an orientation, which can be thought of as an internal arrow, which distinguishes the string from one with the opposite orientation. By contrast, an unoriented string is one with no such arrow on it.